So we find so to find work done by movers on the chest. So this is A. Find the work done by the movers on the chest if they lift it straight up. So work done by the movers on the chest and work done by the gravity on the chest, two cases. Work done by the normal. Okay, this is what we have to do. So now the first step, remember in A we finding done by the movers on the chest if they lift it straight up at a constant speed. So use this formula. We use the formula, and then from there we know the force by the chest, which is 1400 Newton, and then we know the displacement, which is the height, which is 1 meter, and then because so let me do, because the force is parallel, to the displacement. They're pushing it straight up, and it's moving straight up. So the angle between the force and the displacement is 0. So I try to put 0 here, cosine theta 0. So they obtained this value, which is positive 1400 joules need for work. And now let's go to B, where we are required to find, I hope the diagram is clear here, and then B, we are required to find the work done by the movers on the chest if they slide the chest up the 4 meter long. So now they're moving it at an angle, meter long ramp at a constant speed by pushing parallel to the ramp. So they are moving it in at an angle now. So let's go over it. So here we're summing forces along the x direction. So we're given this plane, and then here we have mg sine theta going this direction, and we have this force so applied going this direction. So hence the negative and the positive there. So because this is 0, remember that the force is equal to m times acceleration, because we're dealing with a constant velocity a, so a is 0, so hence here we equate to 0. So now this is the equation we have for B, and since we're not given the angle, maybe we go down there, since as you can see from this equation, we need to have an angle here. So since we're not given the angle, we can use trigonometry at our advantage. So we go for sine is equal to opposite over hypotenuse, and then we have the height, which is this height, which is the opposite, and then we have this stretch, the ramp, which is our hypotenuse, as you can see here. And then instead of sine theta, now we put these values, we have these values actually, we put these values into the equation up there, into this equation. So this is what we obtain. So this is what they obtain. So working out here, so they obtain this equation. And then now, because remember from the equation of work, so now we need to go and put the force there. So when you do that, can we write the equation? So the equation for B will be work done is equal to force times cos theta, then times the distance, which is d. So in this case ours, we put this here, and then because now they are pushing the ramp, applying the force in this direction, and they are pushing the ramp, they're pushing the chest at this direction. So the angle between the force and the displacement is 0. So that's why we put cosine 0 here. Then let's go over. So this, I'm trying to explain this part, and then remember we have obtained here, and then we put it here. So the d, we cancel d, and then all that and that and that. So we get this, and we also get the same work. We obtain the same work. Maybe to highlight this, yes, we obtained the same work, or the work done was the same, but you could clearly see that the effort was higher in A than in B, because maybe let me do this. So let me do this. The effort here, let's focus on the force. So here the force, or the effort, let's call it effort in this case, it's 1400 Newton. And then when you go down here, you just focus on the force. So it will be 350, I think 350 Newton. So for the same amount of work, here the effort was less. So this is just what I wanted to highlight. C, let's go over to C. Find the work done by gravity on the chest in each case. So this is the force, and then you know that, okay, in this case you would say work is force times distance here, because when you talk of cos theta, and the theta is 1, so that's why we have, and here the distance is the change in the y direction, because we're talking of the vertical direction. So when you work it out, you'll have something like this, and then you will have a negative work. It means that actually gravity is taking out, not adding, it's taking the work is transferred from the object instead of to the object. So this is the indication. And then let's go to D. Find the work done by the normal force of the ramp on the chest. Assume that all the forces are constant. So the normal force, so this is what they want. So this is the normal force here. And then now, because it's 90 to the, when you want the angle, the displacement is this direction, and you want the force by the force by the normal is in this direction. So obviously force by the normal would give us the work done due to the force by the normal will always give us 0, because when you put 90 here you get 0. So that's that. So let's go to, maybe let me pause here.